Hello, thank you for watching my video on transformations. This will be part 1, and I will talk about the base function f of x equals x. So, it can be kind of hard to understand what the base function f of x equals x actually looks like. And so for this entire video, we're going to go ahead and use the graphing calculator. And that way it's just so you can instantly see what happens. So, if we have the equation f of x equals x, in our calculator we're just going to go ahead and put it in as a regular y. Okay, even though it is a function right now because of the function of x, we're going to go ahead and put it in as a y equals. So really it's not going to be any different. So we're just going to plug in x and we're going to graph it. And so as you can see, the base function is really just a straight line at a perfect 45-degree angle. So I can draw this. Okay. Alright, and so that is the base function. We'll call this f of x equals x. Now, and so in transformations, we're going to be dealing with a modification of the base function. So if we had the base function, and let's say that we took it this way, so undo that. Let's see. Okay. All right. So if we took the base function f of x, okay, and equals x, and let's say that we added 2. Alright, and so let me get a different color. I'm going to do blue, I think, here. And plus 2. What does that do to the original function? Well, if we go back to our calculator, okay, and we're going to leave our original function in y equals x, okay, we're going to go down here, and we're going to create x plus 2. And we're going to, just so that we know and recognize it, we're going to go ahead and make it bold. So as you can see, I've pressed enter here and highlighted it to be bold, and I hit graph. So what happens? Well, if you can tell, and it's kind of hard to tell from looking at this screen, but the base function shifts up 2 because of the plus 2. And so really, we get something that kind of looks like this. Okay? And this would be our f of x equals x plus 2. Well, that's not the only kind of transformation that can take place. What if we did it yet another way? So let's take this back to white. Okay, make it white. So what if we took this down and made it into, what if we did f of x equals 2x? Here, let me go ahead and let's put the x here. Let's go ahead and change it, and we'll do, since we did blue, we'll do red. What if it was f of x equals 2x? And so we can go back to our calculator and we can kind of bring it over to the side here, and I can click y equals, and I can go ahead and change this bolded one to 2x, and then I'll delete the rest. Okay, so as you can see, the original function, okay, the original straight line is still right here in the white, and as you can see, the 2x actually makes it more steep. Okay, so it actually, now if you were thinking about it as a ski slope, if you were on this slope and you were skiing down, you wouldn't be going very fast, but if I put you on this ski slope, you'd be going down a lot faster, and that's because this line is steeper. And so if we can draw that here, we can kind of show you what that looks like. And so we have, start right there, okay, and we'd kind of go a little bit more extreme, and it would calm down. Okay, and so this would sort of be an f of x equals 2x. Now, let me go ahead and change my color back to white. Alright, now what happens if we took this and we went just a step further, okay, so just a small step further than this, and we made it f of x equals, and I'm going to go ahead and change the thing again. Let's say if I did, let's do green, negative 2x. So what happens then? Well, let's go to our calculator and see what that does to the base function. So there's our base function. It's still the original line. We're going to go ahead and change that second one, and we're going to input negative 2x in there. We're going to hit graph, and we're going to see what happens. Okay, so as you can see, it's the steeper line from the 2x, but now it's on its way downward. And let's see, we can actually graph this in there. So kind of a steep line. and this would be f of x equals negative 2x. Alright, so I'm sure that you're probably wondering where this is all going. Well, this is going to be kind of the last place I wanted to take this video. So let's go ahead and get original colors. Alright, so let's say that we were here. So putting these things together, what if we had f of x equals negative, let's say 2x minus 4. So what does this even mean? Well, and I'm going to go ahead and get the yellow out for this. This means that not only do we have a downward sloping line because of this negative, okay, so not only is it downward sloping like this one down here, this green one, but now we can also say that it is a steeper, so it's steeper because of the 2, steeper. It is a flipped line because of the negative 2, and it is shifted down 4 spaces. So we go 1, 2, 3, 4, okay? And then it's going to be the steeper line, so go ahead and get this one. Okay, and this line is going to be, and so let's go ahead and see if this is what we get. So we have f of x, let me back that up a little bit, equals negative 2x minus 4. So we go over to our calculator, we're going to plug it all in and see if our yellow line is correct based on what we know. So we're going to do negative 2x, and I believe it's negative 2x minus 4. Go ahead and graph it. Aha, there you go. And as you can see, mine is not to scale, but as you can see, it did cross at the negative 4, and it has been shifted downwards, and it is just as steep as the other one. Maybe it's a little bit crooked, but it should be perfectly parallel. So I hope you can kind of understand what transformations are and what they kind of do, and I hope you'll understand that every function, every equation we use actually starts out with the base function x. So even the very beginning, y equals x, okay, that essentially is the base function there. And everything that we do to it, whether we add 2, subtract 2, add or steepen or less, not less steepen, but change the slope, and that has the effect on the outcome of the equation. Well, I hope you enjoyed my video. Thank you for watching.